Hello guys, today we will learn about Hooke's law. Previously, do you still remember what is elasticity? Yes, elasticity is a material property that can change in size and shape after being subjected to an external force, but the object will return to the original size and shape after the external force is removed. In real life, of course, we often encounter the phenomenon of elasticity. And first, let's watch the following video about the phenomenon. What's interesting about the video? Yes, it's about motorcycle shock breaker. When a heavy load is carried and the motor pays through the bottle, the shock absorber or shock breaker of the motor quickly stretches and starts again. And when the passenger get off of the motorbike or the load is reduced, the shock breaker will return to its original length. And now, to better understand about the phenomenon, I'm going to run a virtual lab with Pat Colorado.
About the Hooke's law in Pat Colorado experiment. Yeah, we can see that there is the spring constant, absolute force, and there's the spring. And we will change the absolute force. First, we apply 20 Newton. So we can see that there are the displacement from the spring, and the value is 0.133 meter. And when we add more force, we apply 40 Newton. 40 Newton. We can see the displacement value is 0.267 meter. And when we add more force, we add 60 Newton. We can see that the displacement value is 0.4 meters. And when we add more force, we add 80 Newton, we can see that the value will be larger than before. There are 0.533 meter. And when the output force is 100 Newton, the value of the displacement of the spring is 0.667 meters. So, based on this experiment, we can see that when the greater of the force will make the greater of the displacement value of the spring too. And we can analyze this through the graphic or in mathematical use. We can see in this Microsoft Excel. We can use Microsoft Excel. We can make a table about the spring constant or K. We can see in this experiment, the spring constant is 150 Newton per meter. And the force, we add 20 Newton, and the displacement is 0.133 like that we get before in the experiment. And we can use the data that we get before to make a graphic or a relation between the force and the delta x or the of the displacement, sorry, or delta x or the displacement value of the spring. And based on this graphic, we can say too that the larger or the greater the force, the greater the increase in the length. Or it can be said that the relation is directly proportional. And through the gradient of the graph here, we can also see that the spring constant used is proven to be 150 Newton meter. Um, there is almost the same from the spring constant that we use. There is we use 150 Newton per meter, and we get the spring constant based on the data is 149.92. It's almost the same value. Or we can say that it is the same. And based on this analysis, we can find the relationship between force, change in spring length, and spring elasticity constant can be written as this: force or F equals to K or spring constant times delta X or the displacement value of the spring.
Okay, so if the mathematical equation of Hooke's law are combined into a form of statement, we can know that the sum of Hooke's law is if the tensile force on the spring does not exceed its elastic limit, then the increase in the length of the spring will be directly proportional to the tensile force. If it's connected with the above phenomenon, we can see that the shock breaker can be shortened because a force is applied, as in Pet Colorado practicum or experiment. When we try to apply a force that has negative value, it will shorten. The greater the force applied, the shorter the spring. And when the force is removed or the person who was riding a motorcycle is ride down, the spring, which has elastic properties, will return to its original shape or original size. This is in line with the Hooke's law that we got through the experiment earlier. In this problem, it is known that the delta x or the change of the size of the spring is 0.5 centimeters and the spring constant is 200 Newton per meter. So through the equation F or force equals to K or spring constant times delta x or the change of the spring, it is found that the mass is 0.1 kilogram. In this lesson, we already know about the Hooke's law. What is Hooke's law, how the equation of Hooke's law, the phenomenon of Hooke's law, and the problem solving about Hooke's law. And hopefully this lesson can add to your knowledge, and see ya.